So today we're going to be looking at using Numpy for processing arrays and matrices of number data. So Numpy is far more efficient at processing arrays in Python. Python lists can contain any type of data, including objects, whereas Numpy arrays are far more specialized and they can only contain numbers. So when we looked at data types, we learned that different types of data types take up different amounts of reserved memory space in Python. But a really useful thing that you can do with Numpy is you can actually customize the memory usage so that arrays use less memory and items are therefore stored more contiguously. This results in it being far more efficient and faster at processing large data sets, as when Python normally stores integers, for instance, it overestimates the amount of memory that might be needed. So you'll probably actually need far less memory than the amount of bytes that are getting taken up. So we can use Numpy arrays to store and manipulate large lists of numbers, whereas if we wanted to work with other types of data, we could simply use plain Python lists or, for example, a pandas series. So when we want to create an array from a Python list, well, first things first, whenever we want to use Numpy, at the beginning of our section of code, we'll need to import Numpy, and then standard practice is to use the alias np, so that every time you want to call on a function in the Numpy library, you can simply use the syntax np dot and then the function name. So in this example, np.array would create a new array from the list of numbers in the brackets. Or if we wanted to create a matrix, so in this case a two-dimensional list of numbers, we would use the same function, array, but we'd simply give it both our lists. So let's go ahead and do exercise 1. So in this exercise, we're going to be creating a Numpy array from a given list. So rather than stating our list in the bracket, we want to be able to call a function and state our list then. So first things first, we need to go ahead and import Numpy, otherwise we won't be able to use the package. And then we're going to want to create our function. So, oh no, sorry. So in this case, def, and then we're going to be calling our function make array. Now this exercise asks for us to also have the parameter numList. So now we can go ahead and create our array. So we're going to call it new array. So just set a variable as normal, and then we're going to use np.array to create our array. But rather than putting numbers in like so, and predefining like setting our array, we can simply put numList, so the variable name here, a parameter in there, and then we can go ahead and print that like you would any other variable, so that when we call our function, we can give the list that we want to set in our array in the function call. So if I go ahead and run that, there it is, it prints out our array. But say I wanted to change the numbers in my array, I can just simply change it in the call of the function, and now my function make array will always make me an array whenever I call it and print it out for me. So as we mentioned earlier, you can actually change the amount of memory that is used when creating an array in Numpy. So it allows you to set the type of number in memory. So for example, you can use int8, which is 8-bit, which takes up 1 byte, or int32, which is 32-bit. I think that would take up 3 bytes of memory. So it allows you to make the memory allocation as small as possible. So by using these, it will take up far less memory than if Python automatically used the integer data type to set the memory amount. So in this example, they've made a variable called new matrix, and then we are setting our matrix, so a two-dimensional set of numbers. So in this case, it's a 2x3 column matrix of whole numbers, and we've used np.int8 so that Python knows that it's 1 byte of memory storage. So let's go ahead and do exercise 2. So we're going to create a matrix of small numbers. So I'm going to go ahead and set my function name. I'm going to call it small matrix. And then again, we want numList as our parameter. So this time it's going to be exactly the same, but we're going to be able to give it, it's going to print a two-dimensional list in the form of a matrix rather than just a simple one-dimensional array. So exactly the same as exercise 1, we're going to set a variable called new matrix, and then we still use np.array, and we still want to put in our parameter numList, but this time we're going to set the memory type to int, what's it in this case, int16. And then exactly the same, we're going to print it out. Now, when we call our function, small matrix, we've only given one parameter here. And you might be thinking, but there's 2 things here. Because we want this to be a two-dimensional array or matrix, we need to make sure that there's square brackets around the entire thing as well as each individual list. So when we run this, it will print our matrix, so each list on a new line. So there we have it, a two-dimensional list. Now, in exercise 3, we're going to do exactly the same thing, but we're going to make a 3 by 3 Numpy array. So, again, we're going to make our function. I'm going to call this one 3 matrix. And then numList, again, new matrix equals. So we set our variable. And then exactly the same as the other exercises, we're going to use the array function. We're going to put numList in there. And then we're going to print a new matrix. And now when we call our function, can you see that there are square brackets round the entire set? So when we run this, it prints each list, or prints the array 1 row per line. And there we have it, our matrix. Thank you.